The word automation often makes us think of factories or production lines churning out multiple versions of the same thing. But automation actually takes care of repetitive tasks, preventing human errors and allowing human teams to focus on more challenging work that creates value, like expanding relationships with customers. Dynamic automation takes this a step further by identifying potential problems in IT systems, then automatically fixing them before they become critical. Dynamic automation monitors a system to keep it healthy and error-free. To understand how, let's look at the key ingredients. First, predictive analytics, which complement dynamic automation by helping to identify trouble spots before they can lead to serious failures. Second, a virtual engineer. The virtual engineer can take action on problems that it spots in the system and is also continuously programmed to handle new capabilities by a service team. To highlight the need for these advancements in automation, let's look at a situation without dynamic automation. Rebecca is a member of a consulting firm working with 4Wheels.com, a popular car rental company. Rebecca and her team have built and managed its car reservation system. She understands that summer is the busiest rental time, and so she schedules needed upgrades to the system. Her team makes changes to the application during the weekend and puts them into production on Sunday. On Monday morning, 4Wheels.com experiences very high demand, as expected, and everything appears to be working well. But despite rigorous quality testing, the application creates unnecessary error messages that begin to queue up and fill the storage. When storage reaches 85% capacity, a monitor alert is automatically set off, creating a ticket to address the problem. The ticket is routed to Jeffrey, whose job is to assess and route these requests to the appropriate team members to resolve them. In this case, he routes the ticket to Andrew, the storage practitioner, who at the time is working on a higher priority issue. As a result, the ticket goes into his work queue. Meanwhile, the system is creating error after error, filling up storage until it reaches maximum capacity and crashes, taking down the entire reservation system. It then takes Rebecca's technical team a full day to restore everything and get 4Wheels.com back in business. But by then, they have already lost many customers, and crucially, they haven't yet identified the underlying cause of the problem. But this whole nightmare could have been avoided. Let's go back and see what could have happened with the help of dynamic automation. Anticipating a busy summer, Rebecca ensures application changes are made over the weekend and put into production on Sunday, the same as before. But this time, her services team employs dynamic automation, which monitors the system, including storage, and acts promptly when needed. Before launching the updates, Rebecca's team applies predictive analytics to years of historical data collected from the reservation system. Data from similar reservation spikes in the past tells Rebecca's team that the storage system was the most likely trouble spot. As a result, they take extra care to program specific tasks for the automation applied in the storage system. And this is where the virtual engineer comes in. The virtual engineer is a software component that uses algorithms to assess and automatically address system issues with a system without human intervention. Rebecca and her team have programmed it with a library of capabilities. The virtual engineer monitors the system for irregularities, much like a children's spot the difference game, except that it's super quick and accurate. When it spots an irregularity, it goes through a series of programmed actions specific to that situation in order to stabilize the system. This is known as a state diagram. In other words, a snapshot of the state of the system and the ideal state the system should be in. With automatic storage monitoring in place, when the error messages begin to queue up and storage capacity reaches 85%, the ticket to address the problem isn't added to the bottom of a queue like before, but is automatically routed to the virtual engineer. Since prior data evaluated by predictive analytics had already flagged the storage system, one of the tasks the team programmed into the virtual engineer was to automatically increase storage space once capacity went over 85%. With this task completed automatically by the virtual engineer, a system crash is prevented. The virtual engineer is also programmed to collect data on issues it currently doesn't know how to fix. It checks the testing log data and sends the results to Andrew, the storage practitioner. He can then conclude that the errors are being created as a result of the updates made over the weekend, and so he makes the necessary changes to the codebase. And that takes a lot less time than it would to restore the whole system after a crash. Meanwhile, data from this situation is collected and analyzed by predictive analytics running on the system. So Rebecca's team not only keeps the system healthy, they can learn from it to prevent other issues. Based on the system's insights, they program new capabilities into the virtual engineer's library, improving the overall efficiency of the dynamic automation. By using predictive analytics and dynamic automation, Rebecca and her team aren't preoccupied fixing bugs and crashes. Instead, they can focus on continuous innovation and improvement of the customer experience. This allows them to help 4Wheels.com keep existing customers happy with a responsive, reliable service and to grow their share of the competitive car rental market.